Matrix A is given as 4 minus 2, 3, 4, and we have to find the ratio of A power 4 is to A square. Now we know that every matrix will satisfy its characteristic equation. So the characteristic equation of A is A minus I lambda is equals to 0, which can be written as 4 minus lambda minus 2, 3, 4 minus lambda is equals to 0. It's minus 4 actually, minus 4, it is given as minus 4. Now this can be written as 4 minus lambda into minus 4 minus lambda plus 6 is equals to 0, which can be written as 4 minus lambda minus 4 into lambda plus 4 plus 6 is equals to 0, which is nothing but lambda square minus 16 plus 6 is equals to 0. That implies lambda square is equals to 10. Now we can write this as A square is equals to 10i because matrix satisfies characteristic equation. So let it be some equation 1. Now A power 4, so squaring on both sides of equation 1 will be A power 4, that is 100 I square, and I square is again I. If we take the ratio A power 4 is to A square, which is 100 I is to 10 I, answer is 10 is to 1, that is option B. This is given as E power I theta, which can be written as cos theta plus I sin theta. So 1 by x will be E power minus I theta, which can be written as cos theta minus I sin theta. Now we have to find x cube plus 1 by x cube whole square minus x cube minus 1 by x cube whole square. Let us see the value of x cube now. X cube is nothing but cos theta plus I sin theta whole cube, which can be written as cos 3 theta plus I sin 3 theta. So 1 by x cube will be cos 3 theta minus I sin 3 theta. So x cube plus 1 by x cube will be clearly 2 times of cos 3 theta, and x cube minus 1 by x cube will be 2i times of sin 3 theta. Now x cube plus 1 by x cube whole square minus x cube minus 1 by x cube whole square will be 2 cos 3 theta whole square minus 2i times of sin 3 theta whole square, which can be written as 4 times of cos square 3 theta plus sin square 3 theta, since I square is minus 1. So the answer is 4 into 1, which is equals to 4. Option A. Now we have to check for which of these cases the given differential equation is an ellipse. The given partial differential equation is dou square u by dou x square into 1 plus x square plus dou square u by dou y square into 1 plus y square is equals to 0. Let it be some equation 1. Let us write the standard form of the elliptic equation. Standard elliptic equation, standard form, which is nothing but a times of dou square u by dou x square plus 2b times of dou square u by dou x dou y plus c times of dou square u by dou y square plus d times of dou u by dou x plus e times of dou u by dou y plus some constant f is equals to 0. Now if we compare equation 1 with equation 2, we'll get the values of b as 0, a as 1 plus x square, and c as 1 plus y square. Now for any elliptic equation, b square minus 4ac must be always less than 0. So this is nothing but 0 minus 4 times of 1 plus x square into 1 plus y square will be always less than 0, which can be also written as 1 plus x square into 1 plus y square greater than 0. Now x square is a positive value, y square is a positive value. Now x can be positive or negative, y can be positive or negative. That means for any real values of x and y, this equation will be always greater than 0. So the answer is option C. To find the limit of the function x minus x cubed by 3 plus x power 5 by 5 factorial minus x power 7 by 7 factorial at pi by 2. Now this function is nothing but sin x. So the limit of sin x at pi by 2 is sin pi by 2, which is 1. Answer is D. Find the directional derivative at a point 2 comma minus 1 comma 1 along I plus 2i, I plus 2j plus 2k of the function xy square plus yz cube. Now let us find first delta f. Delta f is nothing but yi plus 2xy plus z cube times of j plus 3y z square times of k. Now we need this delta f at point 2 minus 1 1, which is nothing but I minus 3j minus 3k. Now we need to find the directional derivative along I plus 2j plus 2k. So directional derivative along I plus 2j plus 2k is nothing but dot product of both the vectors 2j plus 2k dot I minus 3j minus 3k by root over 1 square plus 2 square plus 2 square, which is nothing but minus 11 by 3. That is nothing but option E.
The slope of the constant enthalpy lines on a TP coordinate system is. Here the options are Clapeyron equation, Joule-Kelvin equation, Gibbs equation, and Helmholtz equation. But the right option is B, that is Joule-Kelvin equation. For a closed thermodynamic system, the net energy transfer in the system is equal to. Here, in a closed thermodynamic system, the net energy transfer is nothing but the sum of the heat transfers and work transfers. So, and the difference between the heat transfer and work transfer is called as the change in internal energy. But for a closed system, the change in internal energy is equal to 0, and in the option, the right option is D. D is the right answer. In the figure, E is a heat engine with efficiency of 0.4 and R is a refrigerator. Given that Q3 is equal to Q1, the COP of the refrigerator is. Here, heat engine is operating between the heat transfers. Heat added to the engine is Q1 and heat rejected from the engine is Q2, and the work done from the engine is W, and it is used as a input to the refrigerator, and here Q3 abstracted from the required space is Q3 and Q4 is heat rejected from the refrigerator. So here efficiency of the engine Q1 minus Q2 by Q1 is equal to 0.4, but here Q1 minus Q2 is nothing but W, which is equal to 0.4 Q1, and COP of the refrigerator is given by Q3 by W, where Q3 is the refrigerant effect and W is the work input, and here Q3 is given that in the given data to Q1, and W equal to 0.4 Q1, which gives a value of 5, and in the option the right option is D. D is the right answer. The most commonly used criteria for measuring forecast error is, here the options are mean absolute deviation, mean standard error, mean absolute percentage error, and mean squared error, and in the option the right answer is mean absolute deviation. A dummy activity is used in pet network to describe. Here the options are precedence, relationship, necessary time delay, resource restriction, resource idleness. Here the right answer is precedence, relationship. Cost of providing service in a queuing system increases with. Here the options are increasing mean time in the queue, increasing arrival rate, decreasing mean time in queue, decreasing arrival rate. So here the right option is C, that is decreasing mean time in queue. A continuity equation for steady flow, two-dimensional compressible flow is. So here the options are rho dou u by dou x plus rho dou v by y is equal to 0, and dou rho u by dou x plus dou rho v by y is equal to 0, dou u by dou x plus dou u by dou y is equal to 0, and u dou rho by dou x plus v dou rho by dou y is equal to 0. But here the given flow is steady flow, but it is a compressible flow. But in compressible flow, the density will be variable. So that the right answer is B. Dou rho u by dou x plus dou rho v by dou y is equal to 0, since density also varies. In a steady internal flow, the velocity is found to vary as 1 by r square, where r is the radial distance. The acceleration in this flow is proportional to. Here, velocity is varying with respect to the 1 by r square, and of course, acceleration is rate of change of velocity with respect to the time, but not to the radial distance, so that it also varies with the r power of minus 2. So in the option, the right option is C. Maximum effectiveness of parallel flow heat exchanger used in gas turbine is. Here the right answer is 50%. So in the option, the right option is A.